Udah, menuliskan contohnya tadi.
Okay, apologies again. I have to sign several urgent documents. Okay. Okay, you should be able to see the slides now. I hope that you have already gone through some of my initial materials on the research methods. We will be going through quickly. This week we'll be going through maybe the initial aspects of parameters, variables, maybe the basic concepts. Before we move on to talk about, let's say, the SPSS and then maybe even the Excel. Now, for those of you who are going to install PSPP and so on and so forth, it might be good for you to start to look at. Okay, sorry again. I have to sign some documents because those documents are supposed to go to Kementerian today. Okay, now, back to where I left off just now. I was saying that if you are looking at the PSPP, PSPP software, if you are installing, it is slightly different as compared to typical Windows. You may have to go here and then click on the PSPP website. Not this one, the other one. And then you'll be brought to this directory. Okay, this directory. You have to unzip everything. There are 42 files over here, and then you have to unzip. And then after that, only then you can install. For those of you, I do not know how many of you are very used to the free software movement, the new Linux movement. This one you need a little bit of tweaking in order to install. Sometimes you are able to install, sometimes you are not able to install, even though they are Mac OS, Apple OS, Mac OS version, okay, Mac OS version, but yeah, expect some unpredictability and so on, and so on and so forth. But basically, if you're using it for general day-to-day use, it should be fine. Okay, it should be fine. Okay, now uh, I'm going to illustrate several things, discuss with you several things about this research from the perspective of you guys, the requirement of you to run your final year project next year. Last week, I already illustrated to you the importance of research, and then how do you look for key information, the databases, and so on and so forth, and maybe demonstrated how you can look up for those information, and I hope that you can use it. Now, the next step that you should be doing that you should be looking at will be to, in preparation for your final project, maybe you should start to look at maybe potential supervisors that you want to engage in order to do your work, okay, in order to perform the projects that you need to do. And whatever that you do, always remember that the final project is actually just partial fulfillment, okay? Partial fulfillment with a graduation requirement, meaning that if you pass your project, but let's say you did not make it for your comprehensive exam, you are still stuck, okay? However, if let's say the reverse is true, then we'll be given a short time to complete a project, then you can get through, no issues. So please don't break your back. My message here is that don't break your back designing a project that will consume or exhaust all your resources just for the partial fulfillment requirement. Okay, so you can no doubt give your heart, give all you have, your entire your heart for the final project. But bear in mind, at the point where you are going to present a final project, should you be selected as one of the finalists, it will be coinciding with the time where you'll be sitting for your comprehensive exam. So it will not be, it will be something that is actually a very, very big undertaking, okay? Because just imagine you'll be stressed for your comprehensive exam, and then at the same time, gunning for the best project. We had several instances here whereby students gave their all for the final project, and then they managed to be selected for the finalists. But the unfortunate thing is that, not to say fortunate or unfortunate, the challenge then being, the presentation was held during maybe one day, a day before the comprehensive exam. So that particular student spent lots of time on the final project, but to some extent that actually affected her ability to perform during comprehensive. As a result, she was recalled during comprehensive. That had a rather devastating effects on her because she never expected that. And I'm not saying that you should not aim for a best project. No, I'm saying that you make sure that you reach a balance in terms of resources and time committed for your final project and your preparations for a comprehensive. Okay, that's why I keep on emphasizing final project is just a partial fulfillment. Okay, partial fulfillment. Whereas comprehensive exam is a mandatory requirement that you need to pass in order to be a practicing vet. Okay, having said that, how much effort that you need to put in depends on how well you understand the topic. And this is actually where we start to talk about research. Okay, research is as what I've already depicted here. Systematic process of collecting, analyzing information. Okay, and you could be looking at the same set of findings from very different perspective. I already covered the key steps last week, okay? But there are certain aspects that I want to re-emphasize again. As what I already mentioned earlier, one good avenue for you to look up topics for your research will be the prior final year projects presented by your seniors, maybe at the recommendation section, or maybe your special interests that you have really more or less uncovered while you are going through this vet program for the past 4 years. Maybe ideas that you got during your Latin industry or anywhere else. And the other thing is that when you are looking for your supervisors, already taught you last week how to look up their areas or topics of interest, which will be very, very helpful. Okay, which will be very helpful. And because from scientific paper as well, you will have gaps. Okay, you have gaps, research gaps that you can actually fulfill. So to that effect, whenever you look at research, you need to identify what you want to do research on. And this is actually where the research focus becomes important. The subject matter to be investigated, objectives and hypotheses, factors and measurable factors. I will be illustrating using maybe some unusual examples, crazy or unusual examples, and then we'll talk about it. Next will be characterization of variables. Then we'll be determining how you're going to examine it. And of course, when you are determining how you're going to examine it, you have to talk about effect size, test power, and sample size. We'll be covering this maybe in the third lecture. Okay, third lecture. And then organization of resources, data collection, data screening, data analysis, and of course, how to write the whole thing up. Now, let's look at this title. Let's look at this chart again. I already covered this, okay? The first thing is getting idea and what will be your research focus. What are you going to look at? Okay, what are you going to look at? And then next will be to characterize your variables and so on and so forth. Okay, now let's look at what you should be doing. Okay, now I was looking for the whiteboard. Okay, never mind. Okay, we'll switch back to that one later. Okay, let's say cannot print. Okay, I think I have to exit again. Okay. Okay, sorry for the interruption. I think I need to do this for a while. Let's say that, okay. Now we are still on the description of what type of how to look at the research process itself. Let me illustrate this to you. Let's say I always like to use this example. Anything that is outrageous will be maybe useful for you, because this is actually how you see relationship between certain parameters. Now let's see raining days, raining and semester results. Okay. Okay, so you are trying to investigate the frequency of raining and semester results among UPM students. On one glance, you might think that this is actually a crazy title. What do you think raining has to do with semester results among UPM students? Of course, there are many arguments to it, and this is actually where research becomes interesting. Okay, research becomes interesting because technically you can relate almost everything. But whether it makes sense or not, whether it can be proven or not, that is a totally different issue. And this is actually where research becomes important. Okay, research becomes important because you need to identify what you are going to investigate, the subject matter to be investigated, the objectives and hypotheses, the factors and measurable factors, something that is measurable. Now let's look at this. What is your objective? Your objective is to see whether a raining season or maybe rainy days, frequency of rainy days affect the CGPA of students. Now, this will be your objective. Now, let me tell you this. Before you can actually start research, you technically need to ask several things. Number one is a problem statement. Number two is actually your objective. Number three is your hypothesis. So what is the problem statement? Problem statement is problem to be solved. Research is always about solving the problem. Objectives will be to propose a solution to the problem that you already identified. Okay, and then how a hypothesis will be how will the solution work. So when I say problem, solution, and so on and so forth, you could be talking about one problem, one solution, or maybe multiple problems, one solution, and so on and so forth. So it could be a lot of problems, there could be a lot of solutions. So and therefore there could be a lot of objectives, a lot of problem statements, and so on and so forth. So in this case, when you're talking about research, the first thing that you need to do will be the problem statement. What are the problems you want to solve? Is raining a big issue among UPM students? Or maybe you have really noticed every time when it's raining, results change, and so on and so forth. Well, that is actually why certain research is actually being triggered. For example, now research into COVID-19 vaccine. Well, COVID-19 kills a lot of people, disrupts a lot of things, and therefore you need to do research to understand its pathogenesis, how it affects the immune system in the body, and therefore you need to know what is the mechanisms that it invades the body, and then that is a problem. The objective now is, but after understanding how it invades, you need to figure out whether there's a way to lock up these viruses from the body so that it doesn't infect the body anymore. So that will be your objective. And the hypothesis will be, we think that by shutting down this receptor, then the virus cannot invade the host. So then we try it out in an experiment and see whether this solution works or not. So now back to this problem statement. These are the three things that you must have in a research. So when you design a final project, or maybe when you design your semester results later, you need to look at what are the problems that you are trying to solve. Okay, what are the problems that you are trying to solve? So problem statement sounds very big, but it's actually just a very simple thing saying, what are the problems you are trying to solve? Because research is always being triggered by problem. Second thing will be, how are you going to solve that problem? So that is your objectives. How are you going to solve the problem? So maybe you stop the rain. If you're a rain god, then you can stop the rain. Or maybe you say that maybe you arrange class sessions that are not affected by the rain, or maybe modes of delivery that are not going to be affected by the rain. All kinds of things. So that will be your proposed solution. And to see how this proposed solution works, it will be your hypothesis. Maybe you say that, by changing the frequency, by stopping rain, or maybe by rearranging the timetable of the class, avoiding rain, then you may be able to improve the results. Or maybe, on the contrary, by shifting away from rain, certain students will tend to go out rather than stay home and study. And maybe results will become worse. So it all depends on how you want to define. So you can see here, research is not only about one solution. It's all about all kinds of possibilities. And sometimes you think that this solution will yield positive results. Sometimes it might turn out the other way. So the key thing is, once you have a topic, you have to identify what are the problem statements associated with it, the objectives, the hypothesis. And because of that, you need to identify factors and measurable factors. So in this case, What will be the factors? Okay, what will be the factors? The factors, of course, will be maybe rainy days, maybe number of rainy days. Oh, sorry, before that, presence or absence of rainy days. This is a factor. And this has to be expressed as a kind of a measurable factor. Maybe you can talk about frequency of rain. You can talk about volume of rain, rainfall over volume of rainfall over let's say 24 hours, because frequency of rain, it can be very light rain, light drizzle, but it doesn't contribute, doesn't disrupt anything, as compared to maybe 1 hour rain that is very very heavy, causing flooding and everything else. Okay, once only, but it caused a lot of flooding, a lot of disruption, versus small amount of rain, like drizzle for maybe once in an hour for 12 hours continuously. You won't get anything. It just maybe some minor disruption. So factors that you have to identify. What will be the factors that contribute to this? Maybe absence of presence or rainy days. Another thing that you want to measure will be the experiment prior results of the students. Okay, that means before they headed into this experiment, or maybe before they headed into the rainy season. Okay, or you might even talk about the health status of the students. Maybe even selection of courses and subjects. All this would potentially affect how all this occur. Health status of students. If let's say those particular students are the type of students who are easily affected by rain. Every time it rain, they will fall sick. Of course, it will affect the results. And then selection of courses and subjects. Some subjects can only be performed, can only be taught, can only be done when the weather is good. So rainy season obviously disrupted. Or maybe certain subjects like hydrology or whatever can only be done effectively when there is water caused by the rain, or maybe study of flood studies. So when there's no flood, no rain, there's nothing that they can do. So you see, these are the factors that you have to consider. Once you have a research focus, like in my case just now, I was talking about raining season and semester results among UPM students. So you think about what will actually be affected here. What will be the factors? And based on these factors, what can you measure? So prior results, you can talk about, maybe I talk about 1 semester prior, and maybe 2 semester prior, and then it's going to measure in grade points, or maybe even grades like ABC. So you have to decide here what you're going to measure. And then health status is just maybe healthy or sick, or anything that is in between. And then selection of courses and subjects. Maybe you will say that outdoor-based courses, indoor courses, industrial training, and so on and so forth. So you see, these kind of things are the one that will allow you to think about factors and then whether they are measurable or not. So we are back to this one here. Factors and measurable factors. So this will bring us to the next step, which is characterization of variables. So you can see here, once you have this variable, you can start to measure. This variable, some of them will be in grades, A, B, C, D, E. Some of them will be in a much more measurable parameter. For example, 18 years old, 19 years old, 20 years old, 21 years old, and so on and so forth. Some of them could be in terms of height. Some of them could be in terms of temperature. So all of them behave very, very differently. Okay? Or maybe selection of courses and subject itself. Or outdoor courses. How do you classify outdoor courses? How do you classify indoor courses? Do all courses that has at least 1 hour of outdoor engagement consider outdoor courses, or what? So these are the kind of criteria that you have to define. So this is actually where you start to characterize a variable, which is the second step here. These are something that is important. So you think about research, you have to think about what factor, the focus, and then the topic. And then once you have the topic, how you want to measure them. Okay, how you want to measure them. So this is actually some. Hold on. Okay, my apologies again. There was a visitor into my room from engineering. Okay, now let's continue. Okay, let's go back to the research topic that we talked about just now. Okay, so you see, based on the understanding, based on understanding of the topics and so on and so forth, you will be able to know what will be the factors considered, and these factors, they do not present their effects just on their own. Sometimes it's actually the effects are being channeled through, or the impacts are being felt through a series of sequences. This is where you need to characterize the variables. Well, that means how variables interrelated or explain each other. For example, let me give you one example like this. We are talking about rainy end semester results among UPM students. And I already told you, certain types of courses may be best taught when during rainy season. Certain type of courses may be affected by rainy seasons. So that is one example already. And then the other one will be health status of students. If they are healthy, they are not fearful of rain, and then they are not affected by the rain, then of course they can always pay attention to the classes and then get good grades. Whereas if let's say they easily fall ill, because of what is going on and so on and so forth. So of course they are not going to perform well. So these are the kind of things that may affect you. And then I was talking just now about frequency of rain, volume of rain, and so on and so forth. Volume of rain, if it falls too much within a certain period of time, it will cause flooding, which may disrupt the classes, facilities, and all kinds of things. So these are the kind of factors that you have to consider. And you also have to know that these parameters are being expressed as whether they conform to normal distribution or not normal distribution. This is actually where we talk about parametric versus non-parametric. Some parameters can be expressed, some are normally distributed, some are not. For example, they are expressed as grades A, B, and C, and D. You cannot say that A is 2 times better than B, and B is 2 times better than C. No such thing. Because they are just grading. They are just grading, unless you have an underlying mechanism to clarify them. But even then, you can see from the marks assigned to each of these grades, you can see that in our system, A is anything above 80. Okay, A is anything above 80. B plus is anything between 79 to 75. And then B will be lesser than that. And you will notice that the ranges for these grades differ, particularly you see between B plus and A. So how can you say that they are of equal weightage? They are not, but they are given just and assigned nominally as a parameter. So once you have all these parameters in place, once you have all these factors in place, then you can start to think about how many sample size that you want to accumulate or collect in order to make your studies more reliable. Okay, more reliable. And this is actually where viable sample size calculation, sampling theories becomes very, very important. And this is actually where the test power becomes important as well, becomes important consideration as well. And this is something that you need to be mindful as well. And this is what we're going to cover maybe in the third session, using software to calculate sample size. Now, once you have that, you organize your resources, then you determine, if you know that you need 100 participants, then you have to figure out how to get the 100 participants. The same thing as what you're going to do later, going to plan and do later for your semester project. You may figure out that I'm surveying 6 factors, and based on that, in order to make it accurate, I'm taking maybe students from DVN1 to DVN3, and then I'm going to measure these parameters. And some of these parameters easily given. For example, male, female, you know immediately. Okay, nobody is going to be hesitant in saying that, unless maybe some people prefer who prefer to go down the non-binomial route, and so on and so forth. And then, but certain parameters will be very difficult for them to acknowledge you. For example, how much money they have to spend for each month. Well, some may be willing to tell you, some may not be willing to tell you, because money and income is always something that is secret. Okay, so these are the kind of things that you have to figure out. Okay, what will be the questions you want to ask, and how you want to make sure that the data that you get are reliable. Okay, and once you have that, then only then you can figure out for your data collection, and the next step will be screening the data for errors and data analysis and interpretation. So once you have this, then only then you can run all this trial. Now let's move back to this chart now. So once you have that, then you can jump to this particular state, this particular step. Okay, this particular step. We'll be talking about effect size, calculation effect size, something that you need in order to understand the topics itself, something that you need in order to make sure that you have enough subjects. Okay, this is really something that is very, very important. And once you have done this, you need to write down what are the methods that you use to analyze them, the interpretation, okay, and then the results. For me, I would prefer, and whenever you write your results, I would prefer for you to report things in a very sequential manner, so that you know what you are managing, you know what you're dealing with. Okay, you know what you're dealing with. I'm very sure by now, whenever you are writing a case reports presenting certain things, if you have some kind of a guide, okay, some kind of a guide. For example, this is my topic, first topic for literature review, and then second topic for literature review, third topic for literature review, and then after that methods, first topic under method, second topic under method, so on and so forth. Your writing process might become much better, much smoother, as compared to you just simply think, okay, after this topic, what I'm going to write. So that means you need to plan. Okay, you need to plan. Now, before we move on, any question? I know that there has been 3 or 2 disruptions. I'm sorry for that. Any questions? Okay, if let's say there's none, let's move on. Now, whenever you write your thesis, one thing that you may want to pay attention to will be maybe some supervisor will actually, you know that basically thesis will have thesis will have this component. Let's say, okay, thesis will have abstract, introduction, literature review, methods, results, discussion, conclusion, okay, thesis technically will have structures along this line. Okay, the abstract, introduction, literature review, methods, results, discussion, conclusion, recommendation, and so on and so forth. Now, which one do you need to write first? People, some of your supervisors may always say that you need to write intro and lit review first. Yes and no. Now, let me put it in this analogy. When you want to introduce your friend to another friend, how would you do it? Okay, how would you do it? Do you think you're going to ask your friend, your new friend, okay, what is to be known about him or her, and then only then you tell it to to the people that you want to introduce to? No, you don't do that. You will actually, the best way will be to understand what your new friend is actually about, and then only then you can introduce him. So similarly, it means that before you can actually write abstract introduction, you need to know your topic. So technically, if you are writing a thesis, you are doing it in the reverse order. You will have to do prior reading. That means you need to understand the background topic, the background. Okay, background. Once you have the background, then you can formulate your objective and so on and so forth. And once you have done that, then only then you run a trial, and then you get to results. Okay, you get the results. Technically, you start with results. Okay, start with results. Based on the results, you need to align the methods. For example, result number 1, talk about raining frequency. Result number 2, talk about raining volume. Result number 3, talk about type of subjects, and so on and so forth. Okay, let's say we use the earlier example as a starting point. So because of that, you need to make sure your results are aligned in the same order as methods. Okay, same order as methods. So if your method says that the first one that you do will be the frequency of rain, second volume of rain, third will be the subjects, then your result should be organized in such a way as well. So first to write will be the results. Now, when you write results, I would prefer that you write one interpretation or 1 point. For example, you talk about let's say frequency of rain. Increased frequency, let's say decreased results. Decreased frequency, increase better results, and so on and so forth. Let's say you get that kind of relationship. So you just simply say that semester result is inversely correlated or inversely related to the raining frequency. So you have point number 1. And then point number 2, amount of rainfall in a year, okay, let's say it's not affecting the result. So you just simply say amount of rainfall has no effect on the semester result. So now you have 2 statements already. So this is actually something that is very, very important for you to understand. Okay, something that is very, very important for you to understand. So this is how you structure your write-up. Okay, structure your write-up. So first, start with results. Each result, 1 point. Okay, one fact or 1 point. Once you have that, it becomes important for you to structure and write your discussion. Okay, I will go into in detail how to write your discussion later. So you need to have that statement to write your discussion. Once you have done your discussion, then you should be able to write your conclusion. Okay, your conclusion. Once you have done this, then only then you can go back and write your introduction. Technically, in this case, literature review is actually a background of your study. Okay, it is also important for you to distinguish between literature review and discussion. Some people think that materials can be placed in lit review, can also be placed in discussion. So what would be the key difference between literature review and discussion? The distinction is very simple. Anything that will make your results look good, that can be discussed in direct relation to your results, direct relation to result, discussion. Anything that is relevant to your research, but set a stage for you to discuss your research and cannot be included in discussion, lit review. As simple as that. So that means when you design a study and when you start to do lit review, because you're getting methods, getting ideas, and so on and so forth, your lit review will be the first thing that you start to compile. But you do not know which part of the review will be useful, which part will not be useful. So you just do a rough review, include everything. Because when you do the actual experiment, only then you will find out what works, what doesn't work in your setting. Okay, what doesn't work in your setting. Then, like what I mentioned earlier, when you write a thesis, go for the results. After that, discussion, okay, and then align it with methods, and then after that, conclusion. Once you have done this, go back and tidy your lit review, because lit review and discussion cannot have the same material. So then only then you tidy up. Once you tidy everything, by then I don't think you need to look at your text again to write your intro. Just close your eyes, close the book, and so on and so forth, and write your introduction based on whatever that you remember. Now, based on that, then only then you have a proper introduction, because in order to introduce your study, you need to have an introduction that is comprehensive, because you may find in certain theses that their introduction doesn't match the content of the thesis, and that is something that is not good. Abstract, on the other hand, are the key highlights, the key selling points of your study. What problem are you trying to solve? What will be your objective? How did you do it? And what have you achieved? That's all. I'll be talking to you again about how to write the abstract towards the end of the semester, just before you start presenting, because you need to find a way to write the abstract. And bear in mind, abstract is also required in your final year project, maybe about a week before you present your final year project. About 1 week before you present your final year project. Okay, and by then everyone will be under a lot of stress. Just like my students now, they are finalizing their final year project, and then they have to submit the abstract, finalize a title, and this and that. Everybody is under stress, so you need to write a proper abstract, maybe about 250 words, and so on and so forth. This one is just for the presentation, and beyond which, when you complete a thesis, there will be another abstract. Okay, there will be another abstract. Okay, now having said that, what will be the key points of each of these segments? The first one, abstract, will be the key selling points of your study. Okay, introduction, the most important will be objectives of the study. The most important thing will be this. Okay, and then methods, results, discussion. Okay, discussion will be key findings here. Commentary on key findings. Okay, discussion is essentially how you want to sell your work. Okay, how to sell your work. Lit review is about your background of your work. Okay, and then conclusion. This is one thing that people always overlooked. Objectives is actually very easy. Conclusion is actually very easy to write. Just answer your objectives. People will simply say that sometimes the conclusion does not declare what you achieve. Because why? Your conclusion does not answer your objectives. You just need to make sure that whatever that you do, you answer your objectives. That's all. Okay, that's all. You answer your objectives, yes, that is conclusion. Now, recommendation and future studies should be done in such a way that will not trap yourself. You do not write recommendations that say, in the current study, we cannot do that because we don't have enough time, we don't have enough expertise. You do not write in such a way that people will question you again and say, Why don't you do it? Since you know. You do it in such a way that, for example, you declare that you found something new, okay, you found something new, but since this design, the current design, does not accommodate further exploration in that something new, because it may require more parameters, more and this and that, and therefore you recommend that in the future you need to investigate this area because you found out that this particular area will yield a lot of data and maybe a lot more information, and then that is actually how you write recommendation. Not something like things that you cannot do, things that you very so obvious that you must do but you don't do. Then your recommendation could be used against you, will backfire against you. So this is actually how you construct your thesis. Always start with your results from your literature review, gather information about the study, and then after that, I would say this is step 0. And then after that, go to your results. Okay. After you have results, tidy up with your discussion, and then streamline it with your methods. Okay. And then based on this, simplify. This one should be step 3 or step 4, no problem. Okay, step 3 or step 4. Once you have this, then only then you go back here. And then once you have all this, there's no problem for you to write your introduction. And I'm telling you what are the key components of each of this section in your paper, in your title, in your thesis, and so on and so forth. You will be preparing this for your semester results. I wanted an abstract. Okay, I wanted an abstract, maybe not more than 500 to 1,000 words. If you follow this kind of method, it will be very, very easy for you to write. Okay, any question at this point? I know this is very abstract. Okay, this is actually very abstract. This is something that you have never gone through before, but you need to do it for your final project, and you also need to do it in order to comment and understand how research work. Any question? Okay, if none, then I will move on to other aspects of the work. Okay. And when you report results, don't be too presumptuous. Presumptuous means you are not based upon evidences. Always based upon evidences. Okay, this is actually how you write discussion. You will not find this anywhere in books. Okay, now let's suppose we have a result saying that increase rainy frequency, decrease CGPA results. Okay, let's say you have that. Okay, let's say you have that. So when you want to write discussion, okay, when you want to write discussion, always refer this discussion to a specific results. Remember, I've told you that when you write your results, always one interpretation equals 1 point. So if you organize in this way, then you will have enough materials for you to write for your results and discussion. Now, let's say the result that you got was that increase rainy frequency, decrease CGPA. That is your result. The next step, when you move on to comment about the result itself, general discussion, so you need to show that general results commentary on trends and outstanding individual results. Maybe you just simply say, okay, in general, the study found out that when you have increased rainy frequency, CGPA of students tend to go down. And if let's say you split between male and female, then you can start to note down whether the decrease in male result is much more pronounced as compared to the female results, or vice versa, or any other factors that you can identify. This is a point where you just make a general comment about what your results are all about. This is discussion. Now, the next 4 steps, okay, 4 steps or 4 approaches will be very, very important for you. First, you need to refer to the prior research and say, oh yeah, and any other studies who has the same result. Maybe you go something like this. It was found that studies by A and B 2002, 2012 found out okay, our current, for example, you start something like this. Our current results is in agreement with those published by A and B in 2012, saying that increased raining frequency was results. Stop. That is statement of agreement or statement of conformance. And then after that, the next statement that followed will be, this is inevitable because research by CND 2014 showed that when when rain becomes more frequent, it stopped certain students from it hindered certain students from accessing their labs, accessing the outdoor activities associated with the course, and as a result, their efficiency of learning diminished. So you see, I already used A and B, one reference, C and D, another reference. And I also explained why, okay, why why your current results agree with the prior results. Then again, you cannot just simply talk about results that supports you. You need to look for results that contradict you, or maybe at least explain it. Then comes from statement of disagreement. However, the authors noted that later studies by F and G 2016 showed that rain itself has no effect on the semester results. Stop. Can you see that earlier? A and B says yes. C and D support by saying what the reasons. Now F and G says that no, it doesn't affect at all. Then after that, you just simply say G and H 2019 demonstrated successfully that students are doing computer science. Okay, students showed negligible effects associated with the pattern based on their studies on 1,200 computer science students. Stop. Okay, so now you see support against. So after looking through number 2 and number 3, conformance and discordance or dispute, it becomes important for you to make a stand as an author here. Number 4 is very important because it will show you whether you are capable of analyzing data or capable of performing critical analysis and determine what is valid and what is not valid. Number 4 requires you to conclude why, after cross-examining conformance point and discordant point put forth in 2 and 3, you are convinced that your current results are valid. Okay, the statement may go something like this. The current study involved courses that has significant outdoor involvement, and therefore it's not surprising to be disrupted for the teaching activity to be disrupted by raining season. In fact, a study by I&J 2020 indicated that reduced contact hours had adverse effects on student performance. And therefore, we felt that the current work is very much dependent, the results of students are very much dependent on the rainy season, because the earlier studies published by F&G that disputed the relationship between raining season and results were actually conducted on a group of computer science students, whereby most of the learning takes place indoors. So this is the kind of thing that you want to construct. You see, just by having these results, but just by arguing, showing results, and just by arguing, you are able to talk about the positive point of that argument, the negative point of the argument, their explanation, and why your study looks good, why your study took that approach. This is the kind of argument that you need to learn how to do. I know in our education system, especially the Malaysian education system, we are not taught to argue. We are not taught to discuss things critically. This is what I'm trying to inculcate in you guys now. Trying to think critically from the from the supportive point of view, and then from the discordance or antagonistic point of view, and see, after considering all these opinions, which view should you take? Okay, which view should you take? You should be able to make a decision. In scientific world, there will be a lot of studies that supports you, and equally more, maybe less, number of studies that you find against you, or maybe inexplicably against you. So it becomes your responsibility to analyze the fact, take a stand, and say why I believe it is so, or why I believe it is not so. So this is what we intend to to inculcate in you in terms of research. So this is something that is very, very important. Now, remember, this is only the commentary discussion on one result, frequency of rain, CGPA. So can you see that just by doing that, you can easily generate what? 7, 8 sentences, 5 to 7 sentences if you follow this method. Okay, 5 to 7 sentences. And if each sentence is maybe about 10 words, you'll be easily getting what? 60, 70 words already. There's no problem there at all. So learn how to be organized, to write results, and then the accompanying discussion. So initially, you use this method, you'll notice that each result will tie to discussion. And after going through multiple times, it may become time for you to mix and match, because it will look very, very boring if you just discuss one aspect and then followed by sentence, pro, against, and so on and so forth. It will look very, 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 very mundane and very repetitive. You don't want that. So once you go through several rounds, you notice that certain facts can be moved up, certain facts can be moved down, certain facts can be jived together, certain facts can be merged, and so on and so forth. Then this is actually what makes your write-up becomes much more interesting to read. And furthermore, since you organize your results in discussion in such a manner, in the focused manner, when you present to your supervisor to read and so on and so forth, it becomes much more organized as well, because some supervisor will just simply cross your page and say, please rewrite. This is actually what I don't really like. How do you know what to rewrite if the supervisor doesn't tell you what to write? So if, or maybe in certain circumstances, they say, I don't agree with your discussion on rain frequency, please remove them. So if you already organize them according to rain frequency, the discussion, and so on and so forth, it will be very easy for you to remove the whole chunk. Okay? And read through and so on and so forth. I can tell you the writing process is actually much more painful than doing the research itself. For a lot of people, they don't mind doing the physical work, but the writing phase is actually the worst phase. So what I'm trying to do here is actually to recommend, to teach you actually how to write your discussion, how to organize your discussion, how to compile and collate your results so that it becomes something that is manageable. Just for the benefit, I have to develop this method many years ago, about 19 years ago, because during my PhD, I was actually practically at the end of my wits already to when I'm writing discussion. The worst part in a thesis is discussion. I can technically wake up in the morning, start on a new page, start with the, all kinds of things, okay, the, whatever, write whole kinds of sentences, but somehow in between, I decided that statement is incorrect and then delete. At the end of the day, before I go to bed, I might end up with the same blank page, the same word, the, and so on and so forth. Might be even less. And because you keep on writing and then deleting, writing and then deleting, writing and then deleting. So this is actually something that you really need to think through, particularly if you are planning to write a thesis and discussion, which is actually the worst part. So you have to learn a technique, how to do that. And this is actually how I pick up that technique. Okay, I need to look at who agrees with my results, why, and then who disagrees with my results, why. And then after that, look at, based on this agreement and disagreement, why I think my result is still valid. Okay, so this is actually a simple approach which I think you can practice as well in order to make your discussion writing much more efficient. Okay, much more efficient. And this is just an example of what I have done. Okay, I posted the results here. Okay, 10 milligram results in 2 hours of relief, 75 milligram results in 6 hours of relief, and so on and so forth. So, so this is actually an illustration of what I've done just now. But even then, I was just using rain season and CGPA. This one may be much better because this is actually pharmacology example. Okay, you see A and B, B and C, F, and so on and so forth, and then talk about. So you see, just by doing this, you can include a lot of references here already. You need to read a lot of things, and showing that you have a good grasp of your topic, and then at the same time you are discussing intensively, okay, specifically on the various aspects addressed by the other researchers and on your research itself. So these are the general comment, conformance, discordance approach, as what I already told you here. Okay, so after you have done all this is actually your statement. Okay, this is actually your statement based on these results. You can go and read this. Okay, the current results showed that the drug is suitable for pain relief in adult candidates okay, as reported by earlier work, because 75 milligram per kilogram doesn't give you any extra pain relief. Rapid metabolism, poor excretion, major reasons linked to this. And however, now the science toxicity observed among adult candidates used in this current trial. Okay, and this is actually how you write it. Okay, this is actually how you write it. Just an example. So then again, another questions that comes to mind will be how much to write, how much to do. This is again another important topic, because the last thing that you want is you are being made use by anybody. Maybe I'm not saying that your supervisor would abuse you, but what I want to tell you is that you are required to write a thesis for graduation. But and then again, the same material can be published in good journals, and then you can claim credit. You can put it in your CV publication, and then at the same time, it will be very invaluable, very much invaluable to your supervisor, because they can use it for to enhance the academic CV and so on and so forth. I'm sure last week I've already shown you how to check the academic paper by your supervisors. Okay, academic paper by supervisors. I've shown you how many I have, how many the academic staff have, and so on and so forth. So in this case, there are examples whereby certain supervisors retain the students just because those students are good and can help them to write and so on and so forth. So it becomes important for you to know what's the limit like. Now, this tier-based diagram will actually tell you what are actually expected for a bachelor's degree, master's degree, and PhD degree. In a bachelor's degree, from the very bottom, you are describing observed events only, minimal explanation or mechanisms. And for a master's, you will be answering how and what. Okay, studies are typically horizontal. For a PhD, the key difference is that you are exploring why. Studies are vertical, and the focus will be on mechanism and processes. So please don't overdo what you need to do, and then make sure that you invest the right amount of time, right amount of effort, especially so since final year project is actually just a partial fulfillment degree. Okay, partial fulfillment degree. So, but of course, those of you who intend to venture into academic area later, it becomes important for you to publish and so on and so forth. For your information, my first paper was published together with Prof here when I was actually in DVM4. Okay, DVM4. That means before my graduation, I already had my first paper already. Okay, first paper. So it depends on what you want. Okay, it depends on what you want. And then I can tell you that publication, writing article is actually something that is very addictive. Okay, once you get to master it. If you don't master it, it becomes something that is a pain. Okay, something that is a pain. So it's up. I leave you to it. So that is the key steps in the research process. Now let's move on to maybe the other aspect. Any question at this stage? No, you either understood me or it's too abstract for you. Is it too abstract?
A little bit.
You're okay, huh?
Okay.
Okay, huh? Okay, then fine. Can I continue with variables, or you want to go for a break for a while?
A break.
Okay. Then we take a 5-minute break. Now it's 3:27. We'll continue at 3:32. Okay, 3:32. Okay, we'll continue where we left off. 332. Okay, now we're going to talk about variable types in research, because with this later, next week, then I can move on to another topic. Okay, another topic. This topic can be very boring, okay, very boring and rather difficult to deliver unless I'm in front of you and I can work with examples, but I'll try my best. Maybe I'll just simplify whatever that I need to say. That's all, because I can practically go on this topic for maybe about 2 or 3 hours if I'm in front of you, if I have the example, because that will be much better for you. But now online, no, I don't think it's conducive. Okay, let me put it this way. Variables are variables that you can use, you can measure, you can manipulate, you can analyze in order to prove something in research, to prove an effect and so on and so forth. For example, to prove, let's say the COVID-19 vaccine works, well, it should be able to reduce number of hospitalization. It should be able to reduce the amount of death and so on and so forth. That is actually at the macro level. Now, to show that whether the vaccine is actually giving you some effect, you have to measure certain things. For example, the level of neutralizing antibody. So those are actually variable, but they occur at various stages and various levels of research itself. So on one hand, when you talk about the efficacy of the vaccine itself, if we're talking about the amount of hospitalization prevented, or maybe the deaths prevented and so on and so forth, that one, it has to be done in a macro scale, and then and using much bigger population and so on and so forth, and it requires a lot of time, but nevertheless it's useful. Another aspect of study is actually to look at levels of neutralizing antibody. That one you can do it immediately, and then after that you just measure on the patient itself what will be the average antibody levels and so on and so forth. That is much more confined to the early stages of research review, where you only have maybe volunteers to allowing you to check the efficacy of the vaccine. But once you deploy it into the masses, into the public, then you need to look at other parameters, for example, hospitalization, deaths prevented, and so on and so forth. Therefore, these are the qualities or quantities in research that you need to monitor, you need to measure, and by doing it, you are able to say whether your research objectives has or have been achieved. Okay, and having said that, they are the focus of research. Okay, they are the focus of research itself, and depending on what you do, your parameters will be very, very different. Now, let's look at this example. Effects of atmospheric carbon dioxide levels on attention span among deviant students in the KVC. Okay, so you can have a lot of parameters. We shall revisit that one later. Okay, the first characteristic, will be whether the variable is actually independent or dependent. Now, you might think that this is actually menial, but why am I saying this is because this is actually a key aspect that you need to understand when you are going to use SPSS later. You put the variables in the wrong places, you may not get any results at all. Let me put it this way. Independent variables are factors. Dependent variables are outcome of those factors. Okay? You need to know who are the independent, who are the dependent, because when you operate SPSS, there will be an independent column, there will be a dependent column. Okay? That's why I said I'll be able to explain it much better if I use the actual SPSS. For me, at this stage, you just remember independent variable as factor. For example, we talk about the rain just now. Okay, the frequency of the rain. Okay, frequency of the rain. So that will be an independent variable, frequency of the rain, because you cannot control that unless you are rain god, whatever. So there will be higher frequency, low frequency. And then dependent will be, in this case, if you are trying to check the effects of the rain on the results, CGPA results, and then CGPA will become the dependent. Okay, CGPA will become the dependent. Or conversely, you can also use another measure and say pass and fail. Okay, pass and fail. So this pass and fail rate will become the dependent on of the rainy season. Or you could be completely wrong and say that, yeah, the rainy season actually has no effect on results at all. It could be something else. So dependent is actually the outcome of the independent variable. For example, you want to see whether the rainy season affected the pass rate or maybe even the marks and so on and so forth. So you are associating a dependent with independent. This is something that you need to understand. Okay, something that you need to understand in order to be able to associate one variable with another variable. Independent variable in that sense is also known as experimental or predictor variables. This is another term that you need to learn because this becomes important in regression if you're performing regression. Okay, you're performing regression. And how you measure them, okay, how you measure them also depends on what you define, whether they are parametric or non-parametric. As what I mentioned earlier, parametric means variable with intervals. For example, 1, 1.2, 2.3, 3.4, 5, 6, 7, they are fractions. Non-parametric is something that is not normally distributed, number one, and number two, it could occur in percentages. It could occur in fractions. It could occur in score 1, score 2. It could occur in grades, A, B, C, D, E, and so on and so forth. Those are non-parametric variables. Now, another key aspect of this independent variable is that they should be exclusive. For example, high rain frequency cannot become low rain frequency. So that means you need to have a distinction. Or maybe juvenile animal cannot be grouped together with adult animal. Or juvenile animal cannot be grouped together with kittens, for example. So animals already classified as kitten cannot become juvenile. So these are the kind of things that you really have to define, because if you don't define it well, you are going to get into a mess. And this understanding of dependent and independent is something that is very, very important so that you know what to analyze. Next will be the working example. Okay, working example. So these parameters itself, okay, this is actually an extension. Okay, extension of the effects of atmospheric carbon dioxide levels on attention span among DVM students in DKVC. Okay, DKVC. So you can actually work on these combinations of parameter. Concentration of CO2 as high, low, medium, or maybe as continuous value, depending on how you define them. You want to see whether high concentration, low concentration affect the attention span. You can do that. And then how do you measure attention span? You can just go for arbitrary or qualitative measurements, very good, good, poor, very poor. Or if you have, let's say, an eye monitoring mechanism, or maybe even EEG and so on and so forth, you can actually measure in continuous values, for example, minutes. You know, for example, how many minutes they are paying attention to the materials that you want to them to pay attention to, if you have access to the visual scanner and maybe even the EEG. But most probably you may not. So you may just simply go for simple categorical parameters like very good attention, poor attention, very poor attention, and so on and so forth. So once you have this, then and only then you can use your independent parameter and measure how the CO2 concentration, either as category or either as continuous values, affect your attention span. Okay, then you may also want to investigate association and strength. Now, these two terms are the one that I really want you to be very, very careful. Causal relationship can only be investigated using techniques like one-way ANOVA, t-test, and to some extent. Okay, if you're talking about association, we are not talking about clinical association, because a big issue, a big misnomer, a big misunderstanding that a lot of clinicians and a lot of students have is association between this factor and that factor. No, if you talk about association in statistics, you talk about correlational analysis. You're not talking about causal relationship. So this is actually something that you have to bear in mind. Always don't use the word association, this associate with that. No. In statistics, in clinical terms, it may mean something, but in statistics, association only means correlation and regression. But in reality, in a lot of clinical setting, you are trying to see whether one parameter affects another parameter. So chances are, you could be investigating causal relationship, and therefore you could be using one-way ANOVA, t-test, and so on and so forth. Okay, the next one will be characteristics of the variables itself. Qualitative versus quantitative. Quantitative things can be measurable. For example, one chick, two chicks, three chicks, and so on and so forth. Qualitative, on the other hand, is something that is perceived. Okay, good, bad, worse. Good, very good, bad, worse, and so on and so forth. So this is actually something that you need to be mindful as well. Okay? Quantitative has better repeatability because if you measure 1 centimeter, then you can verify again with another ruler 1 centimeter. But qualitative, very different. Very difficult to verify. Okay, very difficult to verify. For example, a painting that looks pretty to you may not look pretty to another person because he has seen far better printing, far better painting as compared to you. So it requires a lot of verification procedures. So it becomes very, very normal that a lot of the data that you could be collecting and easier to analyze will be quantitative in nature. The next one will be attributes. Okay, attributes of a variable is something that is important. I will not dwell deeper in this because this one requires me to demonstrate using a series of parameter and then drawing on a whiteboard, and then only then I'll be able to describe to you. And at the same time, I need to look at the reaction of the class, whether they look puzzled, they understand, and so on and so forth. Otherwise, there's no point for me talking about this. For me, in this case, attributes means whether the data can be categorical, discrete, or continuous. Okay, what is categorical? Categorical is something like that I've already illustrated here. Yes, no, male, female, day, night, young, kitten, juvenile, adult, senior. Okay, those are categorical. Next will be discrete variable. Discrete variable, that means you can only have whole numbers, 1 cat, 2 cats, 3 cats. Well, unless you are in a post-mortem and the animal is already dead, and then only they can have half a cat. But even then, it doesn't mean anything. Okay, because they are already dead. Okay, discrete variables only allow for whole numbers. Continuous is what you normally see every day. Okay, you can see that 1.2 meters, 34.56 kilogram, 7.8 liters, and so on and so forth. There is another issue with this continuous variable. They may or may not conform to normality. Why is conformance to normality important? Because a lot of statistical tests, t-tests, ANOVA, and so on and so forth, is being done based on the assumption of normality. The next one will be the causality or relationship between variables. This is actually what we spoke at length earlier. Okay, causality. That means how much does it contribute, and then is this parameter important for the other parameter? For example, when you measure BMI, you know BMI is actually a function of height and body weight. So if you do not have body weight or do not have accurate body weight, how are you going to get an accurate BMI? Impossible. Okay, impossible. So this is actually something that you need to know in parameters before you can actually explain them. And then whether certain parameters will be independent or not, and then whether they are measurable or not is actually another thing that is actually something that is important. For example, you want to measure attention span. What is the best way to measure attention span? Are you talking about just rating? Or are you talking about maybe much more better electronic devices like the EEG and so on and so forth to monitor brain activity? They might be better. And characteristics, these are already covered, parametric, non-parametric. Okay, so this one is related to categorical, non-categorical. Okay, parametric, normally distributed, non-parametric, not normally distributed. And it includes, you see, non-parametric includes discrete numbers, ratios, percentages, converted numbers, and all kinds of things. Because non-parametric will not be able to stand on its own unless you have a reference point. For example, cow A is 20% heavier than cow B. So what is cow A's actual weight? Well, one of them needs to have a precise reading. Otherwise, it's completely useless. Parametric, on the other hand, is fixed. 1 centimeter will be 1 centimeter here at the end of at the edge of the universe, provided that the guiding physical principles are the same. Okay, and so on and so forth. Now, based on that, you can have a whole series of analysis. I'm sure a lot of you have never seen some of these tests, and this is actually the main idea why we need to go through this series of tests. For some of you who have gone through STPM's STM's probability module, okay, statistics module, because STPM I think has mathematics and statistics. Statistics module, you may see some of this, but even then, I don't think you see Mann-Whitney, Wilcoxon, Kruskal-Wallis, and so on and so forth. You may see something simple like t-test, I guess, to some extent. Depends on what you're looking at. This is a schedule. They will actually allow you to see what type of analysis that you can perform. With what type of data. Now, if you are doing parametric, that means data that is normally distributed. Okay? If you run independent t-test, and then the equivalent non-parametric will be Mann-Whitney u-test. And then you are doing paired t-test, the equivalent will be Wilcoxon sign rank. One-way ANOVA, equivalent non-parametric method will be Kruskal-Wallis. We'll be covering most of this in SPSS. SPSS will allow you to do all this. Okay, SPSS will allow you to do all this. So it becomes important for you to analyze and at least know how to interpret this. Okay, at least know how to interpret this. And then again, correlations. Okay, correlations, parametric correlations and non-parametric correlations. Some of these are very important in medical sciences because it allows you to, for example, project the life expectancy, risk ratios, contraction of probability of an organism getting a condition, getting a disease, and so on and so forth. So this will be something that will be relevant and important to you, so that you can, so that you know what and how to deal with them. Okay, other characteristics. The sixth one will be characteristics that are useful for certain analysis. This one I have to demonstrate to you because just by describing to you, I don't think you can appreciate this. I'll just go through quickly. Blocking variable is something like this. Okay, blocking variable is something like this. You know that drugs has variable effects if you are giving it to the older patients versus younger patients. Okay, so that means when you are running a trial, you need to group patients into young and old, for example. So when you do that, you are blocking the effects of the drug by, let's say, age, because of the different levels of maturity or different level of reserve capacities of the internal of the detoxification organs of these patients and so on and so forth. So this is actually something that you need to be mindful. So you need to block them. For example, I only have senior group. I only have healthy and fit middle-aged group, for example, or maybe a very young, very healthy youth group, and so on and so forth. So you block them by their characteristics and then you analyze them in order to see whether one particular factor is important or otherwise. The other one will be dummy variable, which is actually being used in regression analysis. Okay, regression analysis. Now, having said that, and having touched on the parametric and non-parametric, that means we are talking about normal distribution. Okay, normal distribution. Normal distribution is actually something that is important because it allows you to predict lots of things. And then normal distribution is also the principles upon which our statistical models are based upon. If without normal distribution, you will not have statistics. You will not have one-way ANOVA. You will not have a lot of things because this normal distribution allows you to normalize the measurements and then analyze and remove factors that may not contribute or contribute adversely to the trial itself, so that you are on the right track. Okay, normal distribution or the Gaussian distribution or Gaussian curve describes natural tendencies of quantities to cluster around an average, following a bell curve distribution. So this is actually something that we need to be mindful as well. Okay, we need to be mindful as well because this one will technically help you to understand why certain distribution is as such. Okay, certain distribution is as such. I will stop here at normal distribution. I will talk about it next week. Okay, maybe next week or maybe the following week because I need to introduce you to Excel analytics first. Because in order for you to understand this, I need to give you more example. I think you had enough for the day already because we're all dealing with numbers. Okay, any question? No question?
None for
I know.
now.
Yeah, I know vet students are quite allergic to numbers. Right?
Prof, I have a question.
Yeah, what is it?
Is it required for us to remember all the formulas?
Let me put it this way. You do whatever that is. I don't believe in formulas. Okay, I don't really believe in formulas. I only believe in something that works. Formulas formulas are only useful if you know how to use them. The answer is no. Okay, the answer is no, but you just need to remember the principles. You are not doing you are not doing mathematics, huh?
Okay, thank you, Prof.
Anymore?
Doctor, I have a question.
Mm-hmm.
Whether do we need to like prepare PSVP for next week? Like, do we need to download prior to the class or?
No.
Okay, thank you,
No,
doctor.
if you can get it done, fine. If you can't, no problem because I have to run it from my terminal anyway. And then next week, I will not be using PSPP yet. I'll be using Excel because there are a lot of things in Excel that you can benefit from. Okay, you can benefit from because chances are before you key in your data into Excel, you may manipulate. Before you key your data into any other analytical software, you could be manipulating them or looking at them using Excel. So there are a lot of things in Excel that you guys have not fully utilized yet.
Okay, Prof.
Yep. Any more? Okay. If let's say there's nothing else, I'll see you on Monday. I don't think I'm able to run the class on Friday. On Wednesday. I will see you on Monday, but hopefully you have reviewed maybe 2 or 3 more materials. Next week I will start with Excel, and then I will also start with maybe the prelim sampling theory as well. Because in 2 or 3 weeks time, okay, you need to think about what you want to do, and then remember that you need to submit to me the list of factors, the list of objectives, so on and so forth that you want to do for your trial, okay, for your experiments, okay. I mean for your semester project, not experiments. At the very least, I need to know where you are, okay, where you are, so that I know that you're on the right track. Okay, any questions? If no questions, then I'll see you next Monday at 2 p.m. And then I will be running Excel and maybe a little bit of SPSS, and we'll see what we can do about it. Okay, so have a good day.
Thank you, Prof.